Okay, welcome back again. Now we are going to talk about bitwise operators. For the bitwise operators, first of all we have AND operator exactly same as this shape. We have OR operator exactly same as logical operator, and we have XOR operator, and it is same as exactly this shape. Okay, and shift right operator is this one, and shift left operator is this one. Okay, so now what are we going to do? We are going to learn all those bitwise operators. So to be able to learn all these bitwise operators, then let us start. Integer a is equal to 5. Okay, now let us put here b as well, and let's see. B is equal to, first of all, A, we're talking about AND operator. Okay, A and let's say 53. Okay, so now what is the result for B? B is equal to what? How does it work? So you see, it's an AND operator, it's bitwise operator. First of all, because that integer value, this integer value is 32 bits, as you remember. How do you show A? For 32 bits, you can show 1, 2, 3, 4. 1, 2, 3, 4 is 8. 16. 24. Okay, 32 bits. As you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are, because it's 4 bytes, 32 bits. But of course, because A is equal to 5, starting from here, 2 to power 0. You remember this? So it was, the last one is 1, and then before that there is 2, before that there is 4, before that there is 8, before that there is some other numbers, but our value is 5 only. Okay, let me put the other numbers as well. 16, you remember this, 32, 64. Okay, that will be enough. Okay, let's put it here. A is 5. Okay, so now this is A, which is equal to 5, which is equal to here. So A is 5. In 5 there is no 64. In 5 there is no 32. There is no 8. There is 4. 4 is, you see, last 3 digits. So this is becoming 1. 4 we subtract from 5. We have 1 in our hand. In 1 there is no 2, but in 1 there is only 1. So as you remember, so then this, if you look at the previous videos, so 5 is this huge number, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1. And the second one is 53 is equal to, okay, this is our second number. Let me just copy it. It's going to be much quicker. That's why I'm going to copy, and then let me make it 0 and 0. Okay, this time in 53 there is no 64. In 53 there is 32. Then, as you see, 1, 2, 3, 4, 5, 6 digits. 1, 2, 3, 4, 5, 6 digits. We're starting from here. So then 53. In 53 we have 132. We took out 132 from 53, as you remember. We do have 21 in our hand. In 21, do we have any 16? Yes, we do have a 16. When we put 16 here in 21, when we take out 16, we have 5 in our hand. In 5, we don't have any 8, so that's why this will stay 0. In 5, we do have 4. For 4, we have 1. We don't have any, we have 1 because there was 4 from 5. We took out 4, so we have only 1. There is no 2, there is only 1. Okay, with the calculator also you can do quickly. So this is 5 and this is 53. Alright, and the next step. Now we are using AND operator. AND operator for what? So AND operator, it's bitwise. Bitwise means, so one by one, all those bits are going to be used for the AND operator. So then, what does it mean? So it means here, I can say B is equal to, okay, here, 0 and 0. You remember 0 and 0 is 0. So then if it is both of them are false, they are all false. Okay. And here 0 and 1. What is the result? Is 0, because if any one of them is false, result is false. 0 and 0, 0 and 1 is also 0. 0 and 1 is also 0. 0 and 0 is 0. Okay, 1 and 1 is 1. 0 and 0, 0, 1 and 1 is 1. Okay, what is this number? So when we look at here, this number is equal to 5. So then, in other words, as you see, A and 53 is 5. Here you are. Okay? So this is how AND operator works. For example, when we talk about OR operator, I'm going to change only a few things here. The first of all, here you are. It is OR operator. Okay, and then we will see what is the result. OR operator. This is 5, as you know. This is 53, as you know. An OR operator, this time not AND, this time it is OR. 0 or 0 is 0, 0 or 0 is 0, so like this until here, all 0. But here, as you see, 0 and 1 is 1, 0 and 1 is 1, 1 and 1 is 1, 0 and 0 is 0, 1 and 1 is 1, and the result is not 5. What is the result? This is, you see, it is almost equal to this one, which is 53. Okay? So then, result is going to be 53. So you can say that, so if we use AND, we choose smaller one. If we use OR, we choose bigger one. It is wrong. It is wrong because I'm going to give you another example just now. For example, because this video, you can pause it and you can redo everything again. I will just change a few things here. I'm going to make it 52. Maybe some examples it may work, but here, let's see if it's going to work or not. If I make it 52, you can pause and you can calculate yourself slowly. Is it true or not? Okay, so then here is the question. So not 54 at the moment, I mean 53 at the moment. A or 52 we are talking about. Let's see. This is 5 and this is 52. If you look at here, you can see it's 52. You can check from the calculator as well. Okay, we are using OR operator, 0 or 0, 0, like this. We are here. 0 or 1 is 1. 0 or 1 is 1. 0 or 0 is 0. 1 or 1 is 1. 1, 0, 0. 1 or 0 is 1. When you calculate here, do it with the calculator if you want. Result is 53. You see? So then A or 52 is 53. So result is 53. You can pause it. If you didn't understand that, when you come to school, you can ask me again. Let me carry on with the AND operator. I'm just going to change the question quickly and we'll see what is the result. it's again 52, and we'll see what is the result. So it is this time AND operator. 0 0. Okay, let's see. AND 0 and 0 0, like this until here. 0 and 1 is 0. 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. 0 and 0 0. 1 and 0 is also 0, because if any one of them is 0 is 0, only this one is 1. So it is 1, 2 and 4. So result is 4. As you see 5 and 52 is 4 when you do bitwise operator. So these two are the main bitwise operators, AND and OR. Okay, so the next step. So then why are we using bitwise operator? We are using bitwise operator to make some calculations more quicker, because we are using with the bits as quick as possible. Okay, let's talk about XOR operator. So this is the XOR operator. So what is B if we use XOR operator? And then this is XOR operator. Immediately all zeros are, as you know, both of them are equal. If they are equal, 1 1 1 1 1 1 1 1 1. Okay, 1 1 1 1 1 1 1 1 1. So this one is 1 1 because they are different. Oh, sorry, if they are same, the result was 0. Okay, sorry, just mistake. I'm just correcting this mistake. Okay, I cannot say that why didn't you warn me, because we are not in the classroom at the moment. Anyway, so in video, unfortunately, I have to cut and repeat, but you understand what I did. Okay, so here, because they are different, result is 1. Okay, if they are different, result is 1. If they are same, result is 0. 0 0 0. 1 1 is also 0. 1 0 is 1. Okay, so what is the result here? 1 2 4 8 16 32. 32 plus 16 is 48. 49. This is the result. Okay, so if you use XOR operator, this is the result. Okay, these are what we have done. The next step, we're talking about shift right. B is equal to, okay, be careful, B is equal to A 1. So what does it mean? It means we do have this number 5, and you are shifting right only one digit. In other words, you are putting 0 from left hand side. Okay, so then here it is. I'm going to take this here. This is number 5 because A is equal to 5. So I'm not going to, what am I going to do? From here, I'm going to push 1 0. I add 1 0. When I add 1 0, this will happen. Okay, you see, I add 1 0 and it is shifted. All of them are shifted, and then it is the last one is dropped down. So when it's dropped down, what happens? Result is 1 2. Okay, is equal to 2. So what happened? This B became 2. Okay. What I have done, if I do only one shift, so one digit has been dropped. If I put 2 digits, then it's going to come 2 times 0, and then 2 of them is going to be dropped. If I put 3 digits, so 3 of them is going to be dropped, because I'm going to put 0 from the left hand side. So what happens here, actually, when I say 1, I am dividing this A by 2. 5 divided by 2 is 2.5. The integer value of 2.5 is 2. Okay, and the other way, when you say, for example, B is equal to, let's say, let us consider that we haven't write this part. I'm going to delete it, and then you can check later. You can pause it and go back later. Okay, like this, even like this too. So then what's going to happen? Again, I will copy this part, and this time from right hand side we are putting 2 zeros. So then when we put 2 zeros, so those how do you say, all digits are moving 2 digits at the same time, as you see here. Okay, sorry. Anyway, so you understand, so that 2 digits from the left hand side is dropped down. So this is our new number now. What is this? 1, 2, 4, 8, 16. 4 plus 16 is 20. What happened? 2 digit that you put from the right hand side. In other words, 5 is becoming 20. 5 times 2 to power 2, which is 4. 5 times 4 is 20. Okay, this is how it works with the bitwise. And let me finish the last part, question mark, and this is special one. Sorry, this is special one. Question mark and colon, and I'll show you here, and then I will finish all operators. Starting from next video, we will talk about I mean, actually I'm going to show you how to make coding. This is the last theoretical part, I can say. Okay, first of all, B is equal to, for the question mark and colon operator, we have 3 pieces, 1, 2, and the last one is 3. Okay, this part is going to have a comparison or any kind of things which is going to show you true or false. For example, A is greater than 10. 4, 7. What happened? Here is a comparison, and the result of this, depending on this result, if it is true, B is becoming 4. If it is false, B is becoming 7. Is it greater than 5? Is A greater than 5? No, then it is false. If it is false, B is becoming 7. Okay, this is how it works. B is equal to 7. This is how it works for the question mark and colon operator. And then let me just write here not 10. Let's say, for example, 2. Is it true? Is A greater than 2? Yes, then B is becoming 4. It is called conditional operator. Maybe we can call it like this. Condition operator. It is nice and useful operator. Okay, thank you very much for listening. As I mentioned, after this video we are going to carry on with the Visual Studio C# coding part. I hope to see you soon.